Hello, so let's take a look at example one together. Example one is on the topic of just a very basic square root of a negative number. Okay, so we're going to try to figure out what is the square root of negative 294. Well, it's going to be some sort of imaginary number because the only thing that can be the square root of a negative is our new system, the imaginary numbers. So taking a look at this, they've done this in 3 steps, starting with negative 294. First, they factor the radicand. There's some vocab here. Radicand is the thing under square root sign. Square root sign is what we call a radical, and under it is the radicand. So factoring the radicand means factoring negative 294, breaking negative 294 up into different factors that are multiplying to give that amount. So we take out the negative 1, which is going to be important later. So this is necessary in any of these, is take out negative 1. And then from there, they've broken it down a little further. They've found a perfect square in there, and then there's 6. Okay, factoring out the imaginary unit means we take this whole amount and we break up into individual factors, 3 individual radicals that are multiplying to give us this complete radical on top. After we've factored out the imaginary unit, which is this guy right here, that square root of negative 1, we can simplify, turning square root of negative 1 into I, square root of 7 squared into 7, and square root of 6 remains the same. We rewrite these 3 all together as 7I root 6. Okay, now I want to make sure that you're feeling comfortable with this step right here, one that says we can take this radical and break it apart into 3 different factors. Now let me give you an example of why this works. First, we're going to do one without square roots. We're going to take a look at this, and we're going to have it look like an area model of multiplication. And I'm going to say if I have the number 4 multiplied by 4, I get 16, which means that 16 is equal to 4 times 4. Now, this is one that just kind of works out nicely. If I was to take this, and instead of saying 4, I said the square root of 4, the square root of 4, and the square root of 16. Well, the square root of 4 is 2, so we'd have 2 times 2, and the square root of 16 is 4, so we'd have 2 times 2 equals 4. We'd get the same thing. So we can write that as square root of 16 is also equivalent to the product of square root of 4 times square root of 4. Okay, so that is this step right here. It's taking this radical, like a large radical here, and breaking it up into its component factors, like we broke this up into these 2 factors. Okay, so let's take a look and see if we can do that with a new one down here. So if we want to simplify negative square root of 75, I'll leave this up right here. So we want to factor the radicand. So I'm going to turn that into negative 1. And I'm going to notice that there is a perfect square in there of 5 squared and 3. Now 5 squared is 25. 25 times 3 is 75. So we get all of our negative 75 there in the end. We are then going to factor out the imaginary unit. We're going to break apart our radical into those separate ones. And upon doing that, we can now simplify to get our final answer. Okay, so down here we are going to have square root of negative 1 is I. This would just be 5. And the square root of 3 does not simplify any further. So when we put these all together, we get 5I root 3. So this is our imaginary root of this negative number.